Hi, I'm Jim Morrish. I'm one of the founding partners of Transforma Insights. I am here at CES 2024 at the IoT M2M Council's booth. Here we are with an attractive backdrop, and I am talking to John Carpenter, who is the North America sales leader for Ignion. And we're going to be talking about asset tracking.
Yep.
Now, asset tracking is an incredibly interesting topic, very diverse. There's so many assets that can be tracked out there, ranging from those in extremely remote locations to those that find themselves in hard to reach in radio wave terms locations to those which are in urban areas or even urban canyons, basements. Meanwhile, the benefits of tracking these devices can be enormous, just knowing where things are, being able to go straight to the cable drum that you need in the yard for the particular job that you've got. So just being able to track that stuff is really important. There must be some challenges there. Do you want to explain? Do you want to go through some of the challenges?
There are a lot of challenges there. In the use cases that you described, there are a lot of environmental factors. Of course, everybody wants their devices to be smaller. There are a lot of design factors that come into there. One of the main things that we see is just the environmental factors, where you have shipping containers that are surrounded by metal. There are industrial environments that have all sorts of environmental factors, and there are even trackers for live bodies, whether that be a human being with a wristband or a badge, or cattle tracker, or even pet tracking, which you have a human body involved that affects the RF performance. So we have those types of challenges that really put a lot of pressures on designers to find something that works.
Yes. So you're talking about environment. This is a really local environment to a tracking device. So the fact that it's on a container, and when I say on a container, it could be on top of it or inside it. Yeah, that makes a difference. And if it's on a cow and that cow turns around, that makes a difference as well. Right? So there's some really detailed environmental considerations there. So how are you helping to address some of those challenges?
So, as you pointed out, the location of the device is very, very important, but also the device itself. Antennas or an RF circuit will react differently if it's on metal, in metal inside of it, a metal enclosure, depending on what else is on actually the board. And as I said, if something is placed on a live body, that has a direct effect on the performance of the antenna. So we're able to simulate that and help customers tune through that. Another key factor that we see is the battery performance for these devices. They're often used in a remote location, so the battery performance is obviously extremely important. The efficiency of the antenna circuit, or the RF circuit, becomes very, very important. So we can help with that with our design process. In addition to that, time to market is obviously important. There are a lot of companies out there doing asset trackers. So it's important to get your products out there in time. There are also certification issues that need to be addressed which are difficult. And antennas get detuned with the materials that we talked about. Antennas can get detuned, and so the design process has to take that into account to keep you from iterating design after design after design.
Yes, and potentially even get detuned as a result of putting an established hardware solution in a different enclosure in order to make it more robust.
The enclosure makes a difference, and then where that device is placed. As I said, if it's on metal or on a body or on plastic, on wood, whatever, every one of those will react differently. So all of those need to be taken into account and simulated for if possible.
So it's pretty clear that the RF environment at the level of an individual device, if you really want to get great performance out of it, and thus extend the battery life, which is what really makes the business case, especially in these remote locations. What's really important is to get the right RF performance. But that could get impacted by all sorts of local things that are going on. So what are you doing to help?
There's three things that I would suggest. Number one applies to anybody, and that would be consider your antenna first, which is unfortunately often not done. A lot of designs will pick the RF module, lay out the board, and then put on an antenna, and they're at a big disadvantage there because that antenna may not work, or it may not be maximum gain in efficiency. So we would recommend that anybody consider the antenna first. You don't have to pick the antenna first, but it should be the first thing that goes on your board.
Yes.
Number two, I would say get help in putting these two things together, and we'd recommend somebody get help. And Ignion does have an online design tool where if you give us the size of your board and your frequency, as well as, of course, the communication protocol, whether it's Wi-Fi or Bluetooth or GPS or whatever, give us those three things, and we will help you select the antenna. We'll place it on the board, and we'll help you with an initial matching network to show you what your peak performance can be. So you've got you've got a head start in that way. Also with that help, after you've got that initial design, Ignion will help with engineering support for any customer who needs that. That is different from what I've seen in other companies. Generally, they have to be very, very high volume or pay a high NRE. We'll help any customer who needs it with that initial layout and also coach them through the entire design process all the way up to certification. That does bring me to another thing to consider is the detuning of the antenna. As we talked about, you take a circuit, you put that in an enclosure, which might be metal or some other material, and then you put it in its working environment, which could be on a live body or on a steel container or whatever that is. All of those serve to detune the antenna so that initial design won't work the same way when it's in the environment. Ignion's solution is we call it a non-resonant antenna. It doesn't have a preset frequency that enables us to take our antenna component, put it on the board. We use the ground plane as the actual resonating element. We include a matching network which tunes that ground plane to the specific target frequency that our antenna actually boosts that signal to help the signal. But because we don't have a specific preset frequency, once you have that detuning effect, and that will happen with any device and any antenna, you will have detuning. But because we don't have a native frequency, we're able to retune it back to the target frequency, where another antenna, if it gets detuned outside of the band set for that antenna, you've got to change the antenna and probably start your whole design over. So it's a big advantage in using what we call this virtual antenna technology.
So you're helping people sweat out those last increments of performance.
We help about every step through the process, but yes, that last bit is very important.
Make sure it's absolutely functioning as well as it can.
Ready for certification.
Okay, and I'm guessing that there are increasing challenges, particularly with your radios and devices. You've got multi-radio environments, and you've got end-to-end, you've got convergence of satellite and cellular, all sorts of things. All drop down with everyone trying to push that down onto one chipset. How's that adding to your complexity?
So it definitely adds to the complexity. As you said, there are multiple frequencies. Every asset tracker is going to have GPS, GNSS. It's likely going to have Bluetooth, and most of them now will have LTE. In addition to that, we're seeing NB-IoT and ultra-wideband for precise positioning. There's a lot of, as you well know, a lot of machine-to-machine out there, which is at lower data rates, but it needs to be very, 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 very exact. In those cases, we do have antenna products that are 2 and 3 port, so you can combine several frequencies into one. But also, as you said, there are new frequencies coming in all the time, which just adds to the complexity of the board. So having an online design tool and engineering support has proven to be very, very valuable for the customer. So again, for somebody looking for that help for us, come to ignion.io and see the online design tool, and we'll help you with engineering support from there to coach you through what can be a very challenging process.
Okay, fantastic. So John Carpenter of Ignion, thank you very much for joining me. It's been really interesting to hear about some of the trials of the antenna environment and the RF world. Sounds great. So thank you very much for your time.
Thank you. I enjoyed it.